parts. We're going to get a start here. And there's 4 parts to a possible graphing of a trig function that can come our way. We're going to discuss the first 2 of them today. So I'm going to bump this down a little bit further because I want you to see what we're going to be looking at overall and then how this is going to work for us. You're like, ooh, this looks like fun already. Okay, this is a general form of a trig function. Now, sine can be replaced with anything. Cosine, tangent, cotangent, secant, cosecant. Can be replaced with any of them. But the 2 parts we're going to be discussing today are letters A and B. A is going to be discussing our amplitude or our vertical stretching. That sounds so much more fun. Vertical stretching. So that value will determine if it gets really, really wide, really, really skinny, something that way. And B is going to determine our period, which again is more of a how long for one complete cycle. When we were talking a little bit yesterday about those patterns and how long did it take them to go from the beginning of the pattern and then start the pattern over, that's what a period is, the length of time that would take for that to occur. So we're going to start taking a peek at how those mess with a base function when we're doing this. So when we're doing them, several things we're going to be looking for. We're going to be looking for maxes. We're going to be looking for mins. We're going to be looking for, they're called X-intercepts. I like calling them theta intercepts instead because we're in radian mode now. So if you are going to do something with the calculator and try to graph it, make sure your calculator's in radian mode. Otherwise, life will be very strange. So we're going to be looking at the ones for now with sine and cosine over the interval 0 to 2 pi. Later you'll find out the reason we do it over 2 pi is that's how long a period is for sine and cosine to get through one complete cycle. So what I'll do for you this first time is I want to explain how this is going to come back to the unit circle again. When we're doing all of these, you may notice I put some select values in on your graph down here. 90 degrees, 180, 270, 360. But they're all in 90-degree increments. There's a reason for that. Those are going to be where you're going to find your whole number values for sine and cosine. So instead of pulling out the whole unit circle here, sorry I went into scratch mode here, but I took my unit circle, I cut out everything else except 0, 90, 180, 270. And the reason I did that was the values that I get at each of those are the values I'm going to get on my graphs. So for instance, bless you, sine, when I'm at 0, is going to have a value of 0. So I can go ahead, I can plot my point there. When I get to pi over 2, my sine value has risen up to 1. So I go ahead, I can put that in. And as I continue to work along, pi, my sine's back to 0. 3 pi over 2, we're down to -1. Because see, all of these things come back to the unit circle. And then 2 pi brings me back full circle. And I would start the pattern over again. So I'm going to get this curve that starts to go. And like I said, if I wanted to double check something, or if I did want to look at it in the calculator, as long as I'm in radian mode, I could go ahead, type in the sine of x, take a peek at it. Looks like a snake slithering along the ground here. But if I wanted to take a look at specific values, now that's where I start to say I like to avoid the calculator. Here's why. Well, if you look at a table, normally, hang on. I want you to see what yours would normally be set up, not what I'd done already. Okay, normally, if you went to your chart, you're going to get all this decimally stuff. You're like, well, where are all the whole numbers like you had? What you would have to do is you'd have to reset your table. So second window, Normally it counts by ones. I can set it up to count by anything I want. If I want it to be counting by pi over 2's, I can do that. Second, and my caret button would get me that, and I could set it to do pi over 2, and there's all my zeros and ones and negative ones. However, there's a couple of downfalls. Of course, you notice it doesn't say pi over 2 and pi, it's all in decimal mode. There's my pi over 2. It's up at 1. There's my pi. It's down at 0. But you'd have to start changing your table set every time your period changed, your amplitude changed. Who wants to do all that? So it's better if I have that understanding of the unit circle, for now, if I'm peeking with a little thing like I'd done there, to get this base graph done. Because if I were to keep stretching it past here, like when I went to 5 pi over 2, it would just repeat the process over and go up to 1, down to 0, down to negative 1, and back up. And this one would go down to the next value, and so on. So, oops. Silly man. So, what I want you to be thinking about with these is having that flexibility. Because sometimes I may only ask you to do it over a regular period. Sometimes I may ask you to expand it. It's going to depend a little bit. Cosine, my base cosine, is going to work the same way. When I get to cosine, if I remember my values with my unit circle, when I start at 0, my cosine starts up at 1. So I already see a difference between that and sine. Pi over 2 swings me down to 0. Pi swings me down to negative 1. You're like, oh, this is going to be another curve. It's just like it's moved over some. And that's true. 3 pi over 2 is back up to 0. And then 2 pi, my complete circle, gets me back to 1, or to a complete cycle. So you're like, oh, so it's like a circle finishes in 360 degrees, and so do my sine and cosine values. And it's true. And so just like before, the pattern would continue. Up, back. So I get my curves. Now on cosine, I don't want to make it a V. It's real easy to just go connect the dots, go straight. No, it's like a V. These are all curves. So I want to make sure I continue to be curvy with them. Okay. Understanding those base graphs and where those base values are, those initial 5, are going to be critical as we get into the other parts, because that's going to make it easy for you to do the shifting, just like we've done shifting with parabolas, like we've done shifting with square root functions and logs. It all runs around the same way. So here's, now that we've got a picture, I'm going to wait on tangent for a minute because there's a slight difference to that. If I come back down here for a second, and we decide we're going to look at our key points, one of the things I'm going to have you do is be putting values with all of these, like coordinate points of sort. And a lot of times I'm going to ask you to label at least like 3 or 4, maybe even 5 sometimes points. So like for instance, if we just labeled our main points within our 0 to 2 pi interval, and it's going to seem strange because you're not used to doing it this way with an x value, but we're going to label our x as our radian measures, and y is still going to be like a normal y value is. So for any of these, I'm just going to label those main 5 points with my radian measure and then my y value. And they're the same values, again, that you get when you're on the unit circle. And if I wanted to label more points, I could, but that'll cover me pretty well for most of these. So then, what can I still find? Well, I can find this other information that I'm being asked about. This is going to be what's called a local maximum, because it might not necessarily on some of our graphs be the absolute maximum value, but in this case it will be. So whenever we see those maximum values, typically we're just going to be using the y value. And you're like, well, now why would that be? If I was just looking over this period, I would write it as pi over 2, 1, because just from here to here, I have one maximum. But if it were to stretch further, I may get multiple maximums, okay? So this, in this case, would be a good way to write it. My minimum value, and again, it's wherever my directions change, would be 3 pi over 2, negative 1. Where's the lowest point in that particular interval is what I'm trying to do. And if I was asked for other things like my x-intercepts, sometimes you may have several. So over my period of 2 pi, I have 3 of them actually. 0, 0. Again, it gets weird. Pi 0 and 2 pi 0. But again, it gives me information that I might need a little bit later in a problem. We discussed a little bit on how long does it take for my complete cycle to end. So when I got to here, it would start over again and go. So typically on a sine graph, my period's going to be 2 pi, which we're going to talk more about period a little bit later. And the amplitude, in other words, the value, whoops, lost my U, that my graph stretches up or down is going to be 1. Because it goes up 1, it goes down 1. But it doesn't go into other values besides that. You can have a negative amplitude. We'll talk about that. But for this graph, it's just asking us how far is it from my max back to the axis or my min back to the axis. So it'll be the same thing when I'm doing cosine. When I start to do cosine, again, I can label my points. So I'd have 0, 1. We'd have pi over 2, 0. Pi negative 1. Three pi over 2 back to 0. And 2 pi back to 1. So if you really thought about it, basically when you're looking between cosine and sine, you're just shifting the graph 90 degrees. If I take this whole graph and go 90 degrees to the right, I'd have the exact same graph. So what's that mean to me? Well, over this particular period that I'm doing it, as far as a maximum would go, I actually would have 2 this time. Because at the beginning and the end, I'm just getting to points where I'm going to see changes in direction. So I'd have one at 0, 1, and I'd have one at 2 pi over 1. It's possible to get multiples. My minimum is going to be at pi negative 1. So what I'm going to attempt to do, that's not a bad idea, is again look for my basic information, my x-intercepts would be at pi over 2, 0, and 3 pi over 2, 0. My period, my whole cycle still ends after 360 degrees, or 2 pi. And again, since I don't have any value sitting in front of my cosine, my amplitude is just going to be 1. So what we're going to do for the time being, because everything that we do today with the assignment is going to be centered around sine and cosine, we're going to do what we've done before with some of the note sheets. We're going to take this one and put it off to the side for a moment. We'll come back as we start building some of the other ones in. But I'm going to move this one over, and we're going to jump in momentarily here. There it is. with our amplitude changes. We talked a little bit when we were looking at the first sheet about what the amplitude is, but we didn't really get to see what effect it would have. Here you get to see a couple of examples, and we're going to draw out a couple of examples too to let you see this. But basically, here's my typical sine curve. Goes up to 1, down to 0, back up to 1. But if I start to put that amplitude value in front, like here it's 2, notice it still starts at 0 just like it did before, but now instead of going up to 1, it goes up to 2. And then it drops back down to 0, doesn't change, drops down to -2, and then comes back up. So it changes my vertical stretch. Because once I have that, and my other color has disappeared, here we go. The same thing is if I put a fractional amplitude in front of it. Still start at the same point, but now where that 1 was, I multiply it by the amplitude, and it goes down to half size, to 1/2. And then you notice it doesn't dip down as far either. It only dips down to -1/2 and comes back up. And the exact same thing for cosine. There's really no difference except for the fact, again, it kind of shrinks vertically when I'm multiplying by the fraction and expands or widens vertically when I multiply by a coefficient or a number greater than 1. And that would be whether it's positive or negative. So to actually get to see how this works, I'm going to flip this over here so we can see how this is going. And I'm going to try to show you a pattern on the ones that are already drawn here before we get to trying to draw these on our own. Here are some examples of period changes. Now, keep in mind, my initial period on any one of these is going to be 2 pi. And I see that on this first one. It's just a regraph of my cosine graph. I started at 0, 1, just like we did on our base. This point here, even though it's not labeled, is pi over 2, just like it was on our base. There's my pi. 3 pi over 2. And it finishes up at 2 pi. It finishes its cycle. However, if I stick a number, a coefficient in front of the x term, so notice it's not out here now where my amplitude would be. It's here where the period would lie. We're going to divide the period by this number, and that's going to make my new period. So for instance here, my period is going to be 2 pi divided by 2, or pi. What happens then is it squishes my graph horizontally. Because you'll notice over the exact same period, 0 to 2 pi, I get not just 1, but 2 complete cycles. Because what happens is, all of those values that I had on the first one, where my main values were, are all being cut in half. So for instance, we still start at 0, 1, but where it comes across here now, at this spot right here, now it's at pi over 4. It's at half the value. When I get down here to the bottom, that's now where my pi over 2 is, because my second dot was at pi, but I cut it in half. 3 pi over 2. If you cut it in half, remember, cutting a value in half is like multiplying by 1/2. Okay, so here when I divide by 2, it's like multiplying, bless you. Each of my angle measures by a half. Half, half, half of this is 3 pi over 4. Because again, 1 over 2 would make it 3 pi over 4. And then when I get to the end, half of 2 pi is pi. There's my complete cycle in comparison to this, but the period shrunk down. You're like, now how would I figure out the next group though, because I've done this cycle? Let's look and see if we can find a pattern. And here's the cool thing about trig. There's patterns everywhere. Pi over 4. This is really 2 pi over 4. Because 2 over 4 is a half. 3 pi over 4. 4 pi over 4. You're like, oh, it's just going to keep going up by a fourth. Right. So here is 5 pi over 4. And then this would be 6 pi over 4, but we reduce it. 6 over 4 is 3 halves. 7 pi over 4. And we finally finish our second cycle at 8 pi over 4, or 2 pi. So, and you'll notice it again when we do it on the next one. Here it was by halves. Pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. So we just kept going by a half each time. Now, this time we went by a fourth each time. You're never going to guess what the next one's going to go by. Divide by whatever my b value is. That's my new period. You're like, oh dear. How many cycles did it do this time? Up to here, so there's 1. Up to there, there's 2. Now we have 3 cycles. You're like, hey, that value and that value keep going together. Right. That's how many total cycles you'd get in that 2 pi when you change your period up. So you're like, okay, where are the values at this time? Well, let's see. This first one, because again, you notice we still keep staying 0, 1. That's not changing at all. This one, I would divide my pi over 2 by 3. It's pi over 6. So you're like, so each one's going to keep going up by another pi over 6. Right. Pi over 3 is 2 pi over 6. 3 pi over 6 is pi over 2. 3 over 6 is a half. 4 pi over 6 is 2 pi over 3, and there is our complete first cycle. So it all goes back to my base graph and then breaking it down from there. I'm taking each of those main values, and then once I see the pattern, it's not so bad. So let's see, 4 pi over 6, 5 pi over 6, 6 pi over 6, which is pi, 7 pi over 6, 8 pi over 6, 4/3, another cycle, so that's 2, 9 pi over 6, let's see, 3 pi over 2, 10 pi over 6, 5/3, 11 pi over 6, and finally 12 pi over 6. And you just see the relationship between them. And that's what we're really trying to work on when we're graphing these particular functions. And it's going to work the same way when you're doing it with sine. So I want to do sine and just sine a 2x with you quick, not going to overkill on this, but let you see how that matchup goes. And then I'll just show you on one other page how this relationship kind of goes together. So I look at sine and I'm like, okay, sine's boring. Pi, talked about this one before. It's the same values as we had with cosine, pi over 2. Pi, 3 pi over 2, 2 pi. Okay. So whenever I use the word base graph or base values, that's what I'm going to keep talking about. If you have an understanding of the base angles and what their consequent y values are, you're going to be able to graph any of these with ease, because all you're going to do with a period is mess with these, depending on what that coefficient value, that b value, happens to be. Because, and I'll kind of leave that off to the side, when I get here, again, my period is just going to be 2 pi over 2, or pi. I'm going to squish this. I'm going to kind of smash it into half the size. So what happened with it when it goes half the size? The same thing that did when we did it with cosine. Pi over 4, because again, pi over 2 cut in half, pi over 4. And I just kind of work it this way. Pi cut in half, pi over 2. 3 pi over 2 cut in half, 3 pi over 4, pi, there's my cycle, and you're like, it looks exactly like cosine except we shifted it. Exactly. And that's the idea that we're trying to work with here. Not to go too overkill on it, but that's the easiest way to make a cycle. And for some of you that really, really like using calculators for everything, you could do this, but remember that table set thing I did with pi? You'd have to change that every time for this based on whatever that first value was. So if you were going to do it for cosine of 2x, you'd need to make it by pi over 4. If you're going to do a 3x, you'd need to make it pi over 6. And there's lots of things that can go cuckoo. Much easier to use your brain instead. Just saying. So finally we get to do something. Okay. We get to do some graph sketching. Like, finally, we don't have to just listen to him talk. We can actually draw. So I look. Okay, my value is out here. That's not changing my period. That's changing my amplitude. So my A value is 2. So remember, with amplitude, all that's going to do is change my base value. So if I'm making my own little graph here, since there's no period change, I'm going to go ahead and I'm going to use the exact same values that we were using on our base graph. Because a lot of times you'll be asked to plot 5 points. So if I use 0 in these 4, I've got my 5 points taken care of. So when I think about back to my base graph, I'm like, okay, sine starts at 0. But if I multiply it by 2, well, that's still 0. So I'll put a dot here. Normally at pi over 2, I'm at 1. But my amplitude is 2, which means I'm going to multiply it by 2. And it's going to vertically stretch my graph. When I get back to pi and it's 0, 0 is not going to move in this case. 3 pi over 2 normally goes down to -1, but I have an amplitude of 2, so I multiply it by 2. And then this gets me back to 0, and I find out I got the same graph, it's just stretched more than a regular sine graph would be. But again, it comes back to understanding what my base graph is going to be. So if you need to jot these down somewhere for a bit, wouldn't be the worst thing ever. So what happens if I have a cosine and my amplitude is less than that? Okay, one complete cycle when we're talking about cosine is going to take 2 pi. So I'm like, all right, this time, since I have that half, I guess I'm going to go ahead and make a half one of these. But it doesn't talk anything about changing the period. Keep my 4 base trig function places to be. And again, cosine starts at 1, but I'm multiplying it by a half because that's my amplitude. So I'm going to start up here at a half. At pi over 2, we end up down at 0. Okay, 0 is not going to move when I'm doing an amplitude. Then we go down to -1/2, back up to 0, and then multiply by that half to come back up. And again, it's a curve. So what we're attempting to do as we do any of these is just going to be to keep playing with the way they go. Now, I am going to go past example 3 because I think we're going into overkill with amplitude otherwise. And we're going to come down to 4 where we can do a little period work. Now this gets a little more interesting. My b value is 2. So I divide 2 pi, my normal period for this, by that, and that'll give me whatever my new period's going to be. So now I have to think about this a little bit. Because I was like, okay, before I could just use pi over 2, pi, 3 pi over 2, 2 pi. I don't necessarily want to have to write all those this time and have a bunch of values in there I don't need. So we said before, it means I'm cutting them in half. Okay. Which means I'm going to be doing by pi over 4s. So as I'm doing this, I'm going to go, okay, through 2 pi. 2 pi is 8 pi over 4. So I have to label my graph so when I get to the end, I'm at the equivalent of 8 pi over 4. So I'm like, okay, 1 pi over 4, 2 pi over 4, reduce it. 2 over 4 is 1/2. 3 pi over 4. 4 pi over 4 is pi. So my first sine curve will end here. 5 pi over 4. 6 over 4, that's 3/2. 7 pi over 4. And 8 pi over 4, or 2 pi. Always get that first one done. If I divided by 2, I always think my first one is pi over 2. If I cut that in half, what's my first value going to be? And then just incrementally go from there. Because now I didn't have any change to my amplitude. There's no number in front of sine. So I say, okay, I got this. Sine. I start at 0. And then I go up to 1. Now this is the part you're going to have to be careful of because you're going to be thinking inside, normally that's pi over 2. Why am I doing this pi over 4? Oh yeah, cut it in half. 0, 1, 0, -1, 0, and just follow the pattern. 1, 0, -1, 0. And what you will find is that I've worked through, I didn't quite get to the very top of my next cycle here, but I can see where it starts and where it stops. Oh, I did make it through. I put my line in the wrong place. So I did 2 complete cycles because my period cut the amount of space I needed for that in half. And then it would be the same thing when I did the 3. We do it 6 by 6. And we're just going to set up this part for that. Remember, 2 pi divided by 3. That would be my new period. I just divide by whatever this number is. But I'm always thinking for that first line, here, I'm dividing by 3, or in other words, timesing by 1/3 is what I'm doing. So if I think about that very first mark here normally, which would be pi over 2, in this case, I'm just going to divide it by 3, or multiply it by 1/3. Once I have that very first mark, I just start counting by 1/6, just like I would if I were in, grade school. 1/6, 2/6, 3/6. I just got to reduce my fractions now, though, because I'm a little older. 4/6, 5/6, 6/6, 7/6, 8/6, 9/6. I have to do a lot of reducing. 10/6. I'm almost there. 11/6. And I made it. The larger that value gets for your B value in front of your period, the more squished you are going to be. Because you're going to you would have, if you graphed these now, 3 complete cycles that would go through those 3 areas. And that gets to be kind of crazy. Kind of crazy. I got one last problem I want to do. Just one. I want to go down, I want to do number 8 on the back of this. And we're gonna look at a few more of these on Monday, but I want to make sure I've given you enough that I think you can play with that worksheet and be successful. I'm going to combo the two things. You're like, oh my gosh, man. I have an amplitude change and a period change, and the period is fractional this time. Oh, this is going to be fun. Okay. Period. 2 pi divided by 1/2. What's that going to be? Four pi. Because if you divide something by a fraction, it's going to make it get bigger because you're dividing by less than 1. Divide by 1/2, multiply by 2. So my period is going to get monstrous now. Because that pi over 2 that I was going to do before, I'm dividing by 1/2, so I'm going to times it by 2. Oh, this is great. So I'm just going to count by pi's. I can do this. And you're like, now why are you doing all the negative stuff? Because you'll notice if you look up above, my range is supposed to be between -4 pi and 4 pi. But we're going to do the positive stuff first. I also notice my amplitude is going to change my values here a bit. Okay, got to get myself a little bit of a base to work with here. I don't want to mess this up. Cosine. We're always starting at 0, which normally starts at 1. We have an amplitude. So we're starting at 4. Now, each time I go, I already have all my values set up. 0, equivalent of -1, but it's -1 times 4. Back up, back up. And then now that I've got this all set, 0, -4, 0, 4, and again, it's a curve. You should, and like I said, we will be going over some more of this come Monday. But that worksheet, the transformations of trig graphs 1, that 24A packet, that has some very straightforward problems with period and amplitude and some of both. But it's all sine and cosine. So I absolutely think you are more than capable of knocking that out.